We are very happy to receive Dr. Khuram Shahzad. He is a associate professor and heading civil engineering department in Institute of Southern Punjab. Professor Khuram Shahzad has 15 years of experience in academia and research and development. He has graduated from UG Lahore and done his PhD from Karlsruhe Institute of Technology, Germany. He has an extensive research work in the field of water resources, hydrological modeling, erosion, sediment transportation, and flood forecasting. He has presented and published his work in many countries across the globe, including USA, Germany, Europe, and Asia. So, Dr. Khuram, you are very much welcome. Please start your presentation. Thank you very much.
Thank you very much. May I have the copy of presentation on the screen? I have already shared it with Dr. Kalim.
Okay. So I request the organizer to share Dr. Khuram's slides.
Just a moment. Hopefully, Faraz will be presenting.
Yes.
Sir, slides are visible?
Yes,
Yes.
slides are visible.
All
So
right.
okay, on the behalf of Institute of Southern Punjab, I would like to thank all the organizer of this conference. So maybe you can move to the next slide. Well, today the topic of my presentation is analysis of the effectiveness of the efficiency criteria engaging the model quality. Well, the outline of my presentation today will be starting from the introduction of my presentation that I'm going to share my thoughts on the hydrological models, their purpose in everyday use, to assistance to the decision makers and the planners, the role of hydrological scientists and the water source engineers in providing the information to the decision makers. Well, the hydrologists and the water source engineers are technically interested in providing the information to the decision makers, and in that case, they have to select the appropriate model. And the selection of this model could be only done by some efficiency criteria. But in the scientific community, the main issue is that there isn't any single universal efficiency criteria that could give us the information about the selection of appropriate model. In selecting the wrong efficiency criteria, we end up in saying the good model a bad one and vice versa. Therefore, I have selected few slides in order to share my thoughts on the importance of efficiency criteria. Uh, so maybe we can move to the previous slide. Okay, thank you. The hydrologists and water source engineers are looking in trajectories across space and in time. What they do with the models, they want to do to complex abstraction of a system or its part thereof by models that enable us to look through spatial and temporal domain in advance. By doing this, we can reproduce the historical and future behavior of the natural phenomena. So whether it is a mathematical model or a physical model or a logical representation of a system, the aim of modeling in water resources is to get some information about the parameters of interest that may be precipitation, discharges, water level, storages, before their real occurrences in certain point in time and space. Or with the help of this model, we can enhance our understanding of the real world, or we can anticipate the behavior of prototype in advance, especially in the case of physical modeling in the hydraulic engineering. So in nutshell, the purpose of modeling is simple. It is to assist the decision makers in planning and designing, forecasting, and predictions. Question is, do the different plethora of models that we use in our everyday use they live up to our expectations. How can we differentiate good models from bad ones? What makes certain model a good choice and vice versa? Whether the physical representativeness of the model is more important than its functional accuracy, or is it justified to attach some same expectation from different sort of models that are metric model, conceptual, semi-distributed to distributed models? So there are a lot of questions. Today I am restricting myself to some very vital question, that is how to define a model. What could be the objective function that makes the model good choice or vice versa? And as we all know that the model could be rated good or bad by these scores. It could be the score of certain efficiency criteria, whether it's Nash-Sitcliffe or it is coefficient of determination, resistance index, or certain any other quality criteria that you decide pre-hand that you are going to use for assessing the quality of the model. Now, the performance of the model could be gauged through two different manners. One is subjective efficiency criteria and another is the objective efficiency criteria. In the subjective efficiency criteria, what we do, we plot a graph between the observed and simulated values, and then we see that how good our model simulated results are fitting with the observed result, and that determines that how well our model is behaving. And on the other hand, in the objective criteria, what we do, we take some kind of objective measures that took out the subjectiveness out of the decision making process. Rather, we rely on certain scores. The first indication on the performance of the model is actually the difference between the observed and the simulated values, whether it is precipitation or it is, sorry, I'm not seeing my presentation anymore. Hello?
Kindly share the Dr.
Yes,
Khuram
yes.
slides.
We are resharing the slides. Please wait a moment.
Yeah, okay. Now, as I was saying, that the difference between the observed and simulated or predicted variables is the first indication how good our model is performing. Either we can take the simple difference or we can the square difference, take its root, but that gives us the initial idea about the performance of the models. And then we have some kind of a non-dimensional measures of gauging the performance. In that case, we can use the Nash and Sutcliffe efficiency criteria, persistence index, coefficient of determination, and these criteria have some kind of added benefit than from taking simple difference between the observed and simulated variables. Please move to the next slide, slide 7. Okay, the point is how we are going to select the efficiency criteria, as none of the efficiency criteria is without limitation, and the selection of poor efficiency criteria make good model look bad and vice versa. There are certain sensitivities attached to each efficiency criteria. For example, if we are taking the subjective criteria in deciding about the goodness of the model, then the judgment varies from one person to another person about its acceptability. And secondly, we lack the comparison between one model to another model or two different runs of the same model because the subjectiveness varies from one point to another. The next thing is to use some kind of the objective criteria. In this case, as I have mentioned, that the simple arithmetical differences between the observed and simulated variables give us, okay, some kind of a hint about the performance of the model. If the error is zero, then we say it is okay. But if we keep on adding the errors in different time series, then they start piling up. But if we keep the negative and positive signs all together in the simple arithmetic differences, then they cancel each other, and then end of the day may have zero errors, but in actuality there are many errors. Therefore, we use the square errors, but it is difficult to compare the model performance into different heterogeneous situations. Therefore, the scientific community has moved toward some kind of normalized objective criteria that includes Nash and Sutcliffe coefficient of determination, persistence index, relative efficiency criteria, and there are certain other efficiency criteria. Next slide, please. But none of these efficiency criteria are without certain limitations and sensitivities attached in certain regions. I have given us you on this slide a depiction of Nash and Sutcliffe efficiency coefficient. On the top of this present slide, I have shown you the equation that what does Nash-Sutcliffe does. It actually takes the difference between the observed and the simulated values and take the square, and then we sum it and divide it with the observed, the difference from the simulated values and the mean of the simulated values, and we subtract it from 1. And then in the range of 0 to 1, we say that our model is good or bad. But the problem is, it could be that Nash-Sutcliffe efficiency coefficient tells you that the model is performing very well, but in actuality, the model is not performing well. I can show you on this graph. So if you can see the green curve and the blue curve, these are the two curves showing the observed discharge and the simulated discharge. And the arrow is showing the difference. The small arrow between blue and green curve is showing the difference between observed and simulated values. And the larger difference between the simulated curve and the mean of simulated discharges is going to show you what we are going to insert in the denominator. As you can see that the difference in comparison to the difference of simulated to simulated values from the mean values is much smaller. Therefore, in actuality, the error could be bigger, but because of the bigger denominator, we can have very good result as per Nash and Sutcliffe efficiency coefficient. So all the data has to do is that it has to be located far away from the mean to look at good one, and the vice versa is also possible. In this manner, if we select Nash and Sutcliffe efficiency coefficient in certain models where the data varies from the mean values on either side, then it could be that we punish the model in certain instances and then we praise the model in other instances, whereas in actual scenario, it couldn't be the case. So maybe you can move to the next slide. So here I'm going to show you the problem with the coefficient of determination. So it is very widely used in the selection of model that my coefficient of determination R square value is closer to 1, therefore I'm going to pick the model. But you will be surprised to know that it is possible that your prediction, your simulated values are constantly underestimated or overestimated, but still you can get the R square value closer to 1. So how it is possible? You can see it through this equation that there are on the numerator, you can see what it does. It actually compare the observed values and its difference from its mean values, and similarly the difference of simulated values from its mean value. Therefore, it is a kind of a covariance, and it could be that these two observed and its observed mean and simulated data and the simulated means, they are closely varied with each other, closely related with each other, correlated. So the both curves, as you can see here, are going upward and downward in same fashion. The observed values in the blue curve and the simulated values in the green curve. So these both values are behaving in same manner, and their means are also parallel to each other. The point is they are very well correlated, and therefore you will get good R square value. But as you can see that in this prediction, in the simulation, none of the value is touching the actual observed discharges. But if you read from the coefficient of determination, you can have very good indication about the model. Therefore, in most of the modeling cases, the R square values declare the model good, but in actuality, the model is constantly underestimating or overestimating. And then similarly, we can move to some another criteria. Maybe move to the next slide, please. So this is index of agreement. So the researcher used this criteria as well to somehow get down the bias. Next, in the efficiency criteria, in this case, what we do, we take the difference between the observed values and the predicted values, and then we divide it with the prediction from the observed mean and the prediction from and the observed values from the observed mean. And in this case, yet again, the denominator get large bigger value than the denominator get large bigger value than the numerator. That's why we get very good score in the index of agreement D, and it is going to give you very appreciable result about the model, but in actuality, it is very badly performing. So maybe move to the next slide. The second issue which I want to share with you at this point of time is that in the selection of efficiency criteria, we need to be very careful from the movement, from the known data values. Normally what we do is we are normalizing our difference with the variance. And what is the variance? Variance is the difference of observed values from its mean value. Now, it is good thing when you're using the model, simulating the model for many years, and you don't have any information for a year, 2 years, 3 years, 4 years. Then the best guess you have about the data is the mean value, mean discharges, mean yearly discharges, mean precipitations, and so on. But in the case of flood forecasting, for example, or the real-time rainfall forecasting, the best guess we have about the hydrological event is not the yearly mean, rather the next previous data, 1 day before, 2 day before. Therefore, we need to check the performance of our model not by taking the difference from the observed value from its mean yearly value, rather taking the difference between the observed value from the available guess to us, that is the previous day discharge, previous day precipitation, and so on. So the performance of the forecasting model especially is wrongly gauged if we are using an absolute cliff or coefficient of determination, because in that case we are using the yearly values which are not the absolute information available to us, rather we have more information available to us in the recent past, that is the previous day precipitation, previous day temperature, and previous day discharges. So here, as you can see, here I am going to show you how it works. It takes the observed value and take its difference from the simulated value, that is all the efficiency criteria are doing on the denominator side. But what is different, it is different on the denominator side, that you are taking the difference from the observed values and the observed values 1 day before or one time increment before that is available to us. So that make this efficiency criteria quite the stricter one, but still more giving the realistic picture. However, this efficiency criteria is not without certain demerits, because this kind of efficiency criteria is going to punish the model if the difference between observed and simulated values is very small because of the fact that we are lying in the low discharge zones, and if the difference between the current day and the previous day discharges are greater, are even smaller, then we are going to get bad result even though our model is performing very well. However, in the peak discharges, the processes index is going to give you good indication about the quality performance of the model, but in the case of low discharges, it's going to punish you. Maybe next slide. So as you have seen that all the normalized efficiency criteria need some kind of a variance, and that variance requires some mean value. And the difference of observed value with the simulated value is usually larger or smaller from its difference from the mean value. That makes the efficiency criteria either lenient or stricter depending upon the magnitude of the variance, depending upon on what factor we are dividing the difference. Therefore, the better approach to use natural cliff is not to use the single yearly mean in cyclic data, rather using the monthly mean, because the best information we have in certain month is the mean of the month, rather the mean of the year. That is going to give you more realistic result by the natural cliff in rating your model, in determining model strength. However, in the literature, what I can see is mostly the researcher is using the yearly mean values. That is not the best available guess available to us. Rather, the monthly means are going to give us the more fair picture about the performance of the model. Secondly, the usage of Nash cliff could be effective only when the best prediction is the mean value. And that is not in the case of forecasting model, because I have just mentioned that in the forecasting model, the best available guess is available to us is the fresh seed from the yesterday. Therefore, in the forecasting model, the persistence index is going to give us the better indication about the performance of the model. But yet again, I have just mentioned you its shortcomings. Maybe move to the next slide. So it is interesting idea at this point of time to have some kind of a universal efficiency criteria that could perform well across the nature of different hydrological models. It could be used for various purposes, planning, forecasting, and prediction, with variable inputs in simulation phase, whether it is a yearly input, monthly mean value available to us, or the past daily data available to us. So the choice of the hydrologist or water source engineer is to have some kind of universal efficiency criteria that could give us some kind of a score from 0 to between some kind of a value between 0 and 1, and with the help of which we can declare the model good or bad, as most of the researchers normally do. But it is very difficult, if it is not impossible, for any single efficiency criteria to satisfy the conflicting demand of the each model. So what the researchers do in that situation, they use the multiple efficiency criteria to rate the model, and by taking their average in some cases. But that is again the wrong approach, because multiple efficiency criteria is going to confuse the reader, because the efficiency criteria should be carefully chosen according to the situation of the model, and only the right efficiency criteria can give you the unbiased opinion about the acceptability of the model, what you are using. Therefore, the best way is to select the one, two, or three appropriate efficiency criteria that are unbiased in the situation, by looking at the trend of the curves of the data and the equation of the efficiency criteria, and then selecting one and rating your model. Now, I'm moving toward the end of my presentation. The following points, what I personally think should be kept in mind while selecting the appropriate efficiency criteria: whether you need to ask certain question, whether the interest is in showing the physical representativeness of the catchment or its functional accuracy, because these two purposes are going to give you to different sort of efficiency criteria. And then next thing you need to ask from yourself is, what is the best predictant available to us in the absence of any model? For example, if we want to forecast about tomorrow, what is going to be the rainfall or discharge tomorrow, the best available guess available to us is the today's discharges, not the mean discharges of year 2022. Therefore, you need to rate the performance of your model with the best available predicted available to you and at the moment of time and space. And next thing is, you need to check if the data is cyclic with the variation in mean across the time series. For example, you can have one mean value of discharges from 365 days, a yearly mean, or you can have different means in different season. Maybe you have 4 different means in 4 season, or you can have 12 means in 12 monthly season, and then you can have different efficiency criteria for each month, because you are using the Nash Sutcliffe, giving 12 means for the Nash Sutcliffe criteria on the denominator side, and in that case it is going to give you more realistic picture in the cyclic data. The next thing which you need to ask from yourself is, what is the purpose of modeling? Because the purpose of modeling, whether it is used for the planning purpose, or it is used for the probability frequency distribution, or it is going to use for the forecasting or prediction. So all different purposes of modeling are going to direct you toward different efficiency criterias. Now, another thing which is very important, you need to look for the stationarity and the non-stationarity in the time series, because again the efficiency criteria are going to give you the goodness of fit in whatever the data you are fitted. So if your time series is non-stationarity in it, then it could be that in the actual run mode you even get good score from the assessment criteria, but still it is not going to perform well in the future. And lastly, if the quality standards are already given by the regulatory authorities and certain margin of errors are selected for the acceptability of the model, then you need to bound by those constraints in before making judgment about the goodness of the model. And lastly, I need to conclude that whenever we do modeling, what we are doing, we are giving the best guess to the decision makers, and in coming to the best guess, we have whatever model we are using, we have two bands of the equation, two parts of the equation. One is the deterministic part and another is the probabilistic part. And what we are doing, we are increasing the band of deterministic part and then narrowing the band of probabilistic
Uh,
part at the errors.
excuse
So
me, excuse me, Dr. Khuram. Sorry to interrupt
yes,
you, but we are 5 minutes above from your time. If you
okay,
can
I'm
repeat
just saying,
any.
I'm last words and I'm over. So therefore, I just concluded. So I have given you my concern about selection of quality criteria in the modeling purposes, because it is very important in the judgment of model about its goodness. Thank you very much from my side.
Uh, Thank you, Dr. Khuram, for the wonderful presentation. It was very useful, especially related to generating the modern trends through simulation and modeling. Thank you very much.